that Evdoxia and I have been doing. It's under the End Users Fixing Fairness Issues EFFI project that is funded by Fujitsu Limited. We are looking at the impact that laser feedback might have on improving AI fairness. So I'll do the first half of the talk, and then Evdoxia is going to give you the results, and we can go from there. And all right. So what's the motivation? So all of that falls under the Responsible AI banner, right? Responsible AI quite often considers fairness, accountability, and transparency. And in this project, we are trying to address fairness, the fairness component of responsible AI. So what we want to ensure is that AI, or an AI model, is free from bias and does not discriminate against individuals or groups. So that's the overall aim. Now, unfair decision-making can actually happen in various ways. So, for example, the training data that we use that is usually captured from humans, right, could be already unfair, right? So you're re-embedding unfairness in the model by having an unfair training data set. Or the training data could actually be fair, but through the training process, we are introducing some bias, and that can happen quite quickly by, for example, class imbalance or anything like that. Then the model sort of suddenly becomes unfair. Okay. So over the last few years, that has attracted a sort of increasing research attention, and there are now some tools out there that help you either find fairness issues or bias, or they can actually mitigate bias and fairness issues. And so one of the most well-known ones is IBA AI Fairness 360, that helps you to find issues in your model. So it typically, I think, has 4 fairness metrics, and it runs kind of it looks for violations of these fairness metrics, usually against protected groups, so gender, ethnicity, and all of them. And then it shows you the results, and then you can also try and mitigate those issues by essentially removing them from the model. There's other approaches as well. FairML is one. Google's What If tool has capability of addressing sort of bias and also fairness. And then there's also some interfaces that have been developed mainly as sort of research tools, like FairSight and FairViz. And I'm showing FairViz and FairSight on the right. So you can see relies heavily on visualizations to find these biases and fairness issues in there. A lot of this work rests on fairness metrics, and there's over 20 of them that measure bias or fairness in different ways. I come back to them as I go on with the talk, because we also use some of them in our investigation. So one of the problems with operating in this space is that you have these 20 different fairness metrics. Some of them are incompatible with each other. So if you improve one, the other one goes down. It's not obvious which one to choose in which context. And also, it's really not obvious who does the choosing, right? So usually, for example, with IBM AI Fairness 360, well, it's the data scientist or the machine learning expert who says, oh, yes, this is the fairness metric that I want to apply in this circumstance. But, you know, who's to say that they are the person capable of making that decision? So based on that, there have been increasing calls to involve stakeholders, including lay users, in fairness as these fairness oracles, right? So much like annotators are oracles deciding whether something is correct or not, you now have this sort of notion of using humans as fairness oracles that can tell you whether a decision that was made by an AI model is fair or not, right? So we're operating in that realm, and we're particularly targeting lay users, right? So these lay users would not necessarily be in a position to make sense of complicated interfaces like that, because they don't have a background usually in these fairness metrics, right? So we think that they might use some fairness metrics or some fairness notions, but we don't know which ones they are, and you know how that actually works, how people judge the fairness, and then how we can use their involvement to increase the fairness. So let me just get rid of this closed caption thing. So before I go into our method, I'd just take a little side route to some of my previous work, which bears some similarity to what we're doing at the moment. So I've been working in what we call explanatory debugging for interactive machine learning for quite a while. The idea is that the system explains its predictions to the user. The user then understands what is going on and therefore can give really good feedback back to the model to improve it, so that it retrains itself. Classic example of an oracle, right? So what we've been doing is we've been doing interfaces that communicate quite a lot of information, explain what is going on, right, to the user. In this case, we were explaining why certain messages were classified as a particular topic, so either hockey or baseball. So we gave them some explanations. We also showed them the feature weights, and the control part is that they can add features to the AI model, and then they can also, by dragging these bars up and down, adjust feature weights, right? So they can literally steer the machine learning model, right? So that's the background where some of this stuff will come from. And then as part of a previous project, we started digging into lay user involvement. And we published that last year in TIIS, Transactions in Interactive Intelligent Systems. And And what we did there was we leveraged that work from explanatory debugging, where we said, well, explanatory debugging identifies bugs in the decision making, and then we give people control to fix these bugs. The context here is very similar. We are letting people find and fix fairness bugs that do not meet their expectations, and we literally use the sort of same mechanism in the interactive machine learning context. We operated in the loan application domain. We used an anonymized data set from a partner bank. And then we recruited some people through Prolific, 388 of them, without any technical or domain expertise. So they were really lay users. The only criteria that we set was you should have applied for a loan in the past or are interested in applying for a loan in the future. So some very tenuous kind of background requirement. We used a logistic regression as the model for this for these loan applications to make a decision or a prediction whether they should be accepted or rejected. We had not great accuracy, but enough. And crucially, after training, the model failed a fairness metric called disparate impact on the nationality attribute. So it was, if you were a foreigner, you actually were more likely to be rejected than if you were a citizen, right? It didn't fail any of the fairness metrics with other attributes, and also crucially, before training, the training data set actually was fair, so it was above 80%. Okay, so what we allowed people to do, much like explanatory debugging, is we got them to label the predictions, and then they were also allowed to change the weight of the feature, right, as feedback. And so what we did afterwards, we used the average weight value for each attribute suggested by the participants on an application, and then recalculated the model. So we did an online study, but offline experiments and offline retraining. This was the interface that we used. So a quick overview, we showed them the sort of how many applications were accepted and rejected, whether they marked them up as fair or unfair. We had a little explanation about how the algorithm worked. So this is an explanation of logistic regression that should be understandable to a mortal human. Then we had some attribute information, so the importance of the feature to the model, value distribution. So we binned some of them and showed this many were accepted and this many were rejected within that bin. A list of applications with a prediction confidence of how sure the AI model was that it is accepted or rejected. The markup, and then when you clicked on an application, it showed the application details here. Here's the attribute with the value and the weight, right? So -1 to +1. And when they click, oh, hold on, there's another one here. So they were able to see how similar other applications were to this selected application. So they could see, for example, this one is rejected, but this one is very similar to it. and accepted what are the differences. So we could show them the similarity score for the between those two applications. Right. When they clicked on suggest changes, another panel appeared, and a little bit like the explanatory debugging, they could pick up those bars and move them, and could adjust the weight of the feature. So they could say, well, you know, don't pay as much attention to that particular thing. And of course, they could mark it up as fair and unfair. Okay, so the results of that, they actually found it useful and easy to use. They were able to find problematic decision through that interface. So they used a lot of sorting and filtering on the predicted decision, the confidence, and they used the comparison quite a lot. 20% of assessed decisions were judged as unfair, and they mostly honed in on that nationality attribute. And then when looking at nationality, unfair was applied to 57.6% of accepted citizens, and 14.4% for rejected foreigners. So we were expecting them to look at all of the the rejected applications for foreigners and mark them as unfair. But actually what they did was the opposite. They looked at accepted applications for citizens and marked them unfair, right? So it's kind of counterintuitive a little bit. And then we had quite a lot of people making weight changes. Not everyone did, but they gave feedback on about 3.71 applications on average. And then when we used that to retrain that model, these weight changes improved the disparate impact to 0.814, which is considered fair, so up from 0.71 or whatever it was. So that's good, but what we also found is that some of these improved the fairness quite a bit, up to 0.91, but then others really tanked it, right? So their feedback was deteriorating disparate impact. So with that in mind, let me go back a little bit to fairness metrics. So we have a lot of fairness metrics about around, and some of them capture various things. So very common fairness metrics are group fairness metrics. So they capture something about the equitable treatment for protected groups, usually, right? Or some groups, right? So you have statistical parity, equal opportunity, equalized odds, conditional statistical parity, and a lot more, right? We also have something called subgroup fairness. So we're looking at the intersection of protected attributes. Black women, for example, is an intersection. So again, we're looking at the equitable treatment of these more granular intersections. And then we also have what are called individual fairness metrics, such as consistency and the Teal index, which capture that similar people are treated in a similar way. Okay. What we wanted to do with our study was we wanted to investigate how to integrate feedback from lay users into an AI model, what works, what doesn't work. And also investigate, so if we integrate feedback, will that actually make the model better, right? And in a way, what we were trying to find out in a roundabout way as well is, well, what fairness metrics do people use? Because we were hoping that we could spot the fairness metrics by kind of going, oh, the fairness is going up on these, but not on these others, right? So our contributions is that we were hoping to create an open data set of lay user feedback on the fairness of loan applications. Applications has gone. But one of the problems is that there are no data sets out there where we can try stuff out. You know, there's plenty of loan application data sets, but none about the feedback on the fairness, right? So literally you have to go out and create your own data set. We wanted to give baseline approaches of how people could do it, so we can put that out there and hopefully people can improve on what we're doing. We wanted to show that it's actually feasible to do this, and then also point out future research directions. So let me go a little bit into the methods. So data and models. So we again used an online study, but then did offline experiments. So it's not a true interactive machine learning setting, right, where you retrain the model continuously after every feedback. So bear that in mind a little bit. We were using the home credit data set. So that's actually a real data set collected mainly in Asia, I think. It's mainly small loans, and we use the payment difficulty to predict whether to accept or reject, right? So that data set actually tracked whether they got into trouble repaying that loan. The original data set has 120 features. We only use 49 of them. We removed some because of blank values. Some others we had literally no idea what it actually meant, right? So we reduced that down slightly, but it still has 49 features compared to, I think, how many does the German credit data set have?
The German.
Yeah. 20, right? So a lot of the other research uses the German credit data set, was developed back in the early 90s, I think. And that has 20 features. So, you know, it's less complex than what we were using. We have 3 protected features in there: gender, marital status, and age. So we calculated a lot of our fairness metrics on those. We used an XGBoost classifier with 100,000 training instances. We did some sampling to deal with class imbalance, and then we predicted on 1,000 instances, which we showed to users through. That's not the whole sort of UI, that's one part of the AI. But we have a list of applications, we show them the prediction confidence, we show them the predicted decision, we give them a little bit of an overview about, you know, how many of the decisions show as accepted or rejected. They are able to filter some of these applications on attributes and attribute values. You recognize this. This is again a sort of similarity distribution. We show them the application details, and then when they click on decide, they can decide whether it's fair or unfair and give weight feedback. So very sort of like a family resemblance between the previous study and this one. Okay. What we did was we recruited 58 participants, half and half, roughly men and women. Through Prolific, they had a 30-minute session, 20 minutes to interact with the prototype that I just showed you. We paid them £5 incentive, and the flow was they got shown the hit. Then we got informed consent on our side. We showed them a quick tutorial how to use the interface, and then they had 20 minutes interaction with that UI that I showed you. we collected logs of the user interactions, so what applications they selected, how they sorted, what feedback they gave, all sorts of different things. We have demographics from Prolific. You get them whether you want to or not, but we didn't use them. So, but we have them on file. We calculated 5 group fairness metrics and 2 individual fairness metrics. EPR, CDD, EOD, AOD, and PPD is our group fairness metrics, right? So that is the baseline fairness of them. We also calculated consistency, the teal index, and then the accuracy. So that is where we started out from the baseline of the trained model, right? What we then did was we investigated how to integrate that. And at that point, I think I'll just hand over to you because you did all of the work.
So we saw in the previous slide the baseline, which is essentially the values of the fairness metrics before integrating any feedback from the participants. So purely by training the model based on the initial training set, that was what we were getting. The point of the analysis then was to retrain the model after integrating the feedback from the participants and recalculate the values of the fairness metrics, and then compare what happens to the model's fairness after integrating people's feedback. So that was the main point of the analysis. When we looked at the feedback that we collected, we found out that there were 58 people that provided us with feedback labels. So we were tagging the loan applications as fair or unfair. So all of them provided this kind of tags. But there were only 59 of them who suggested feedback weights. So this made us to think that there might be alternative ways of how we could integrate this feedback into the training set of the model. So we focused mainly on 3 approaches. Of course, there were more, but we couldn't do everything possible. So the 3 of them, which we focused, were integrating only the labels, the feedback labels, both the fair and the unfair of them, into the training set. The second approach was focusing mainly on the loan applications which were labeled as unfair by the people. And the third approach integrated all the feedback instances for which we actually had both labels and weights. For all of these 3 approaches of integrating people's feedback, we tried 2 approaches of retraining the model. So the first one, the one-off, was essentially training a global model. So we were integrating all people's or participants' feedback at once into the training set. And we were retraining the model in one instance, and then calculating a new set of fairness metrics. So we had the original, the baseline set of fairness metrics, and the new one, and we were comparing these 2 sets. In the IML approach of retraining the model, we simulated essentially an interactive machine learning way of integrating people's feedback. So we were getting their feedback instances or ordered by the timestamps that they provided that. And we were integrating 1 feedback instance per time for separate models for each one of the participants. So we had essentially 58 separate models trained upon the individual feedback of the people. Let's see now what we got. The first approach of training, the one-off approach, was essentially, we tried that essentially to help us choose fairness metrics and attributes. So because people, actually they didn't have any guidelines as to what might be fair or what might be unfair. So they were naturally labeling applications based on what they believe what is fair or unfair. Our aim was to see which of the fairness metrics they might have intuitively picked to improve, or which attributes from those present in the data set they might have focused on exploring. So this is why we considered all this group of different fairness metrics. So in the first approach, we tried to integrate all people's feedback at once and retrain the model using the three different approaches of integration and see what happens to these fairness metrics. Originally, we were expecting to see some patterns. So, for example, we were expecting to see the fairness metric, a specific fairness metric improving for all the protected attributes. So here we consider the three protected attributes, or something different like some fairness metrics improving for certain attributes. But as you can see, there was not a consistent pattern shown across all the three approaches of integration. We were mainly seeing that in the second approach, where we focused on the unfair labels only, we could see a consistent improvement of DPR and AOD across all the three protected attributes. That was the only thing that we could find. As far as the accuracy is concerned, I didn't mention that. That was consistently dropping in across all three approaches of integration, but this is somehow expected because we see it in all the bias mitigation approaches, where we try to mitigate bias and we sacrifice essentially the accuracy of the model. So that was expected. And as far as the individual consistency is concerned, the consistency in the tail index, we see that it mainly drops consistently, with the exception of consistency in the first approach, but that was a very minor improvement. So based on these findings, we believe that we could focus on DPR and AOD for the second approach, so taking only the feedback instances that were labeled as unfair by people, and see what happens if we apply an interactive machine learning approach of retraining the model. So let me explain a bit what was taking place here. You see these graphs at the bottom here. So the blue lines, every point of the blue line give you the value of the corresponding fairness metric after integrating a single feedback instance from a participant. So what you see here is the output of a single participant. So every time we were integrating one feedback instance, we were retraining the model, recalculating the fairness metrics, and that is a point in a single point in the blue time series. Then we were calculating the red ones, which is a smooth version of the blue ones. And the black horizontal line gives you the baseline value. So what was the value of the fairness metrics before integrating any feedback? So we were calculating then the percentage of change of the red lines from the baseline and an average of that value. And we presented that in the graphs above. So each bar in the bar charts above corresponds to a single participant. So to the model that we retrained for that participant and shows you the average percentage change of the corresponding fairness metric. And we sorted the participants in descending order, right? So what we can see from the graphs above is that there is most of the participants were improving DPR and AOD on gender, which is in alignment with what we found in the previous approach of training. But we see that almost overwhelmingly, the marital status and the age is deteriorating. That was strange because in the previous analysis, we found that marital status and age and DPR and AOD on these attributes were improving. So this made us to believe that there should be some effect of like people trying to pick an attribute, improve fairness on that attribute, and this might cause some possibly unintended effects on other attributes. And we can see this effect if we look at the feedback of that individual there. So the first line shows you the DPR and AOD on gender, and if you look at the red lines, you see that there is an improvement of the fairness metrics on gender. If we go in the second line, the marital status, we see that the red line follows the baseline. So essentially, the participant follows the baseline in this case, while if we go in the last line, the age, the red lines are below the baseline value. So it seems that fairness deteriorates on age. Yeah, so what else we did? We tried the clustering approach. Why? Because we wanted to see if there is any consistent pattern among the participants as to how they pick the fairness metrics and the attributes and how they try to improve that, or if we can by like doing a clustering spot any pattern of these conflicting effects. So we tried here a K-means approach, if I remember well. We did some grid searching for spotting an optimal number of clusters, which was 3. And then, so the vectors that we used contained the average percentage changes of DPR and AOD on gender, marital status, and age for any of the participants, and we clustered the participants. We got 2 large clusters, the orange and the green one, and 1 small cluster, the red one. So in the 2 large clusters, what you see is that most of the participants were improving the DPR and AOD on gender, while there are only a few of them improving the marital status, the second column, and there in the second column. And as far as the age is concerned, in the first cluster, there are a couple of participants who are improving age, while in the second cluster, there is no participant improving age. The last cluster is a really small cluster. The people there only like brought a really small change in the DPR and AOD on age and gender, so very small changes there. And all of them were deteriorating fairness on marital status. So on average, we could say that these people were essentially deteriorating fairness. So that was what we found through the clustering. And then there was another thought that we had, that probably we see these effects because there might be a case where people might not have interacted with what we believed they would, actually the protected attributes. So we consider gender, marital status, and age as the ones that we would expect people would focus on. But then we said, okay, let's go into the log files, the interaction log files, and see what people actually interacted with. And these were the three attributes that they mainly focused on. So what we see here is I think the 10 attributes that people interacted the most in descending order. So you see in the second column the number of participants who interacted with each one of the attributes. And then in the third column, the average weight change, which was suggested by the people. So what you see is that gender is only in the second place with 23 people who interacted with that attribute, while marital status and age were not that much of interest for people. What is interesting here is that there were many people that considered the fact that an applicant might own a car or not should not play a role in the decisions for loan applications, which this attribute is not protected, right? But they thought that this is something, it is unfair to rely a decision on an attribute like that. So they suggested a big decrease in the weight, in the importance that the model sets when it makes decisions based on this attribute. Is that the last one?
I think, yeah. It switches over, I think. Yes.
Yeah.
Do you want me to take over? All right. Okay. So those were the results that we got so far. Limitations, we only calculated a subset of fairness metrics. So 5 group fairness, 2 individual fairness. There's more out there. We might have missed some that people might have chosen. As Evdoxia has already mentioned, we only tried some approaches. We actually considered more in the outset, but we only had limited time to really fully explore 3 of them. So there's definitely other approaches that we could try in integrating the feedback. And I said before, we did an online study with offline experience, so not a real IML setting. So what that meant is when they gave feedback, they were essentially kind of flying blind as to the effects that was having, right? So they didn't see whether that changed any of the predictions, any of the fairness metrics, anything that we were giving them. So that is definitely a limitation because they just didn't know what happened to it. So in terms of what all of this means is, I think there's definitely sort of 2 sides of this coin. First, about sort of human-centric, human in the loop fairness. So one, we don't have a clear winner in terms of fairness metrics. So we can't say, oh yeah, choose this fairness metric and everything will be fine. It seems that people perhaps use different fairness metrics, certainly different attributes. It seems like people pick perhaps 1 or 2 to optimize, and then, and they might not necessarily be protected attributes either. So one of the things is that probably we need to let people choose attributes that they want to investigate in terms of fairness metrics. But what seems to have gone well is to use this wisdom of the crowd. So in the one-off approach, we actually did see fairness go up, for 2 fairness metrics, but overall that was actually really increasing the fairness of the AI model. There's also some technical improvements that we could make. Again, perhaps other better ways of integrating user feedback. We welcome everyone to beat our baselines, right? But one of the things that is also holding us back as a field, really looking at fairness, is that there is no standard way of calculating these fairness metrics, right? So we made a lot of assumptions when we calculated them. So for example, consistency depends on the number of similar people that you choose, right? Usually that is set at 5, right? So you use a cluster essentially of 5, right? But obviously, the bigger you make the cluster, the more difficult it is to achieve high consistency, right? Because you're sort of saying, you know, as many people as possible get treated in the same way. So, you know, it really heavily depends on the size of that cluster, and there's no standard way of setting that. And then lastly, in that clustering that Evdoxia showed you, there were these 4 or 5 individuals who seemed to just make fairness worse across the board, right? So what do we do with them if we're actually going towards wisdom of the crowd, right? We probably don't want to have them in there. What do we do with this poor fairness feedback? Can we actually identify these people in cluster 3 early, so we know that they're providing not good feedback to us that might actually make our models less fair? Another point is about who we should involve. So we tried this with lay users, but really the work is in its infancy about, you know, involving all kinds of these stakeholders like domain experts, perhaps regulators in the future that might want to look at fairness of decision-making AI models. And our case really just looked at this sort of model design aspect. But you could imagine a case where we want to involve these stakeholders at different stages of this AI development lifecycle pipeline, right? Where we involve them in making decisions or assessing fairness when we're collecting and cleaning that data, when you know, we're doing testing and evaluation, and then also what happens after deployment. Are we, you know, how can we make sure that these AI models and AI systems stay fair? So I think that is about it. Just a quick summary. So we collected fairness feedback from 58 lay users on loan applications. We tried out 3 different approaches in 2 settings. We have the code available and the data set if you want to try your hand at that. The accuracy and individual fairness dropped sort of when we tried these different approaches, but when we used feedback in a crowdsourced setting, just using the unfair label, then we actually saw improvements against DPR and AOD for the protected attributes. When we looked into individual users, we saw that they differed quite a bit in how they adjusted fairness and on what attributes. But what is also becoming clear is that they might not use these common fairness metrics or notions because they also include other attributes in their choices. And I think that's it. Evdoxia is happy to answer your questions. Alessandro.
bias, some inherent to our cognition. So how can we be sure that we are not simply replacing the bias of whoever was behind the data with the bias of the user?
Good question. I think there is always that danger that, that especially lay users are not less biased than, a loan officer who actually makes these decisions. I think that's an interesting point that bears some investigation, right? Currently, though, the practice is that fairness is not even assessed anywhere other than data scientists, right? I wouldn't want to rely on that, right? There is no guarantee that lay users might make it better, but at least it's sort of drawing that from a much larger pool rather than just relying on one person to make the choice for you. I think that's the answer. Whoa. Tanaya.
So how do you ensure that the training set that you're using is exactly fair? And I think there was probably similar papers where we didn't discuss like in the context of the attributes that you later use for the names. Is there any statistical test that you do that people who give off loan and people who didn't give loan, they are like matched in terms of gender, things that we use, so that we know that it's exactly fair training set?
So the we didn't calculate the fairness of the data set, but this is the baseline of the model that we developed, right?
I didn't understand this one, to be very honest.
So what we did is we calculated 5 group fairness metrics. So they are commonly used.
After you get the results. Right?
Yeah.
So not on the training set. So
No.
training set has like unfair data to begin with, like if you have 2 binary classification, 2 classes, one class is more data for let's say one gender or one.
Yeah. So we didn't do it on the original data set because the data set was slightly different to what we were doing. So the original data set just gave whether they struggled to repay or not. And then in our model, we try to predict whether we should accept them or reject them based on the repayment struggles, right? So slightly different. Oh, no, I've gone too far. Right. So with this study, we actually did calculate the original and it was fair, right? And then fair. It was over 80%, right? But when we trained the model, suddenly we introduced an unfairness on the nationality attribute. So you're right. We could sort of calculate it on the original data set, but we didn't. We just focused.
I know if that's a valid thing to do. I don't know, but makes me think that that's a very important aspect in this.
Yes.
That you start with a fair data and then it's still not working.
Yeah. So in this study, we didn't worry so much where that unfairness was coming from, but we just noted what people were doing to change that baseline fairness of the model, right? So, but yeah, that's a good point, and there's sort of other ways of addressing unfairness that looks much more at the training data set. Yeah.
So the first thing was, what I would like to say was that first of all, we wanted to have some room of improvement. So we didn't expect the predictions of the model trained on the original data set to be fair, because we wanted people to
That is something that is not going to not be fair. That's
so-
given.
No, it's that, for example, if you see the TTR on gender, there was 0.76. We consider this as good when it is above 0.8, right?
Yeah.
So there was some small room of improvement for people there to go and like say, oh, this application, I think, is unfair, and I want like to improve the PR so I would like it as unfair so that I can increase the 90%.
So you think it was intentional to have this kind of
It was not, we didn't like work on the data to make it intentionally unfair, but we were expecting to have some unfairness in there so that we can see how people react to this unfairness and what kind of people will react. Not just that, in the second, even if the original thing said is fair, after retraining, it is like often we encounter some biases which are coming in the prediction because of the way that the model learns to make predictions. So we might learn some correlation between some attributes which might introduce us into the unfairness, which was not present in the original data set. It has to do with how the model learns. Actually, it depends on the outcome. So we might, for example, even if we had calculated the fairness in the original thing set and it was fine, and then train the model and we calculate that, we might like find that some of the aspects of fairness will be different because of the introduction of these biases by the way we communicate. So I think there are some papers in the literature where the bias mitigation or the bias mitigation approaches for this reason because of how the systems learn.
Unfortunately, it's already 2 p.m.
Yeah, sorry.
Stay longer, you can have a further discussion with us. No, but there's also a question online which I will paste on the GIST channel. And
Okay.
I guess the room is available, so if anybody wants to stay further to ask further questions, you can stay. But yeah, thanks so much.
Happy to stay and answer the 2 questions that weren't asked yet. So this is currently under